Hello, and welcome to my tutorial series on how to make a 2D platform in Unity. In this video, we're going to continue working on our character movement. Let's get started. So right now when we hit play, our character moves back and forth. And the first thing that's the problem is that he is always facing the same direction, which is the first thing we're going to fix. The other thing is that the way we have this set up right now with our script right now, he moves in terms of creating a new vector, which is fine, but when you create a game, you want to have your controller feel good to your player. And what we're going to do today is we're going to add acceleration to the movement of our character. So he won't be moving just at one flat speed. He'll sort of speed up to a max speed where he'll remain. And likewise, when he slows down, he'll decelerate back to zero in the same manner, and that will be in the video after this one. So let's get started adjusting our script to create this. So now we're going to go into our Fabio script, and the first thing we're going to do is we're going to make some new variables. We're going to create a private float, and we're going to call it minimum walk speed x. And we're going to set that to 0.25f. So in the previous video, we set some floats up here, but we didn't set them equal to a number yet. You can do it both ways. You can set something up and then use it later on for a value, or you can set the value immediately when you declare it like we're doing up here. And probably later on, we'll set this up so we can publicly use it in the Unity editor, but just for now, I'm just going to put this number right in. It's mostly based on my experience with making platform controllers, so it could change later on. We'll have to adjust it to what we feel is right about the game, but right now I'm just going to leave it at 0.25, and whenever you're using a float and declare float, you need an F at the end for float. So the next variable is a private float, and that's going to be walk acceleration and an X for the X-axis that this is all going to be on, because there's also going to be accelerations for the Y-axis also. So we're going to create that 0.14f. So everything is actually called walk for the base speed because there's going to be a faster dash that's going to be used in the game, similar to a Mario game where if you are moving and you push the B button, he can run a little faster. So I'm just using walk to differentiate between the variables that are going to be used for the regular base speed and the dash speed. So next after that, we're going to have private float, and that's going to be called current speed x. And that's not going to be set to anything right away. It's going to vary as the character moves. And then we're going to have a last private float called max walk speed x. And we'll set that to, let's say, 5.5 f for now with a semicolon at the end. And lastly, we'll also have a private bool, and we're calling is changing direction and a semicolon at the end. And we haven't gone over bools yet, and we will a little bit more in the end of this video or towards the end of this video when we start using it. A bool is basically meaning that something is true or false. So in this case, the true or false is that he's changing direction. So he can be not changing direction, or he can be changing direction. And that's where the bool comes in. And you'll see when we do that code how that works. So now we're going to be adding a new function to join our void start and void update. And this is going to be called void fixed update. And with curly brackets, and this should be a capital F. So the void fixed update is very similar to the void update. The biggest difference is that the update, as it says here, is called once per frame. Now, what we want to start doing is we want to start using physics. So physics works better in fixed update because fixed update is more designed towards the physics engine and can actually be updated out of actually more or less than 1 frame per second, which is how we want our physics to work. And actually what we're going to do is we're going to move this right here, our movement. We're going to cut that, and I'm going to put it into the fixed update up here. And this is where we're going to use it from now on because it's more physics based. However, the input of our controller, that can be remain right here in the update function. And now we're going to change up some things also. Going to go ahead and we're going to comment this out. And I don't know if I explained this before, but as you can see up here, we have these two backward slashes, or forward slashes rather. And then it tells us, you know, what the start function does and the update function does. These are both comments, and so is this. So anytime you see words in green in code, or at least in C# and other C code, it means it's commented out. And when something is commented out, it's not part of the code. So these are comments that are being used as notes, which is a very common way to use comments, of course, because it's called comments. But you can also do it if you want to just take some code out temporarily or maybe permanently, but without deleting it. So I'm going to do that right now. So also in this, in these two if statements right here is where we're going to put the code that's going to help our character move, or excuse me, face the direction he's moving in. So actually, no, wait. I don't want to comment this out quite yet, because I'm going to need it to show you how that works. So we're going to put transform dot local scale, and that's going to equal a new vector2, and that vector2 is going to be 1, 1. And then we're going to put a semicolon at the end. And we're going to copy this, and we're going to put this down here also, and I'm going to paste it right there, and we're going to put a negative. So local scale refers to the ability to scale our character. Go back. Like in terms of what we have, oh, let me click on it. We have a scale right here that we can use to size him, but we can also flip our sprite like we did here. Only we can use this local scale code right here to do that. We're just saying when he faces this direction, his transform.local scale, the change in his local scale is going to equal this new vector, and it's going to be 1, 1. He's going to be positive in the X direction and positive in the Y direction, which means he's going to be facing upwards. And this right here is facing right. And down here, it's going to be the same thing. He's going to transform his local scale, and it's going to create this new vector, and it's going to be -1 in the X direction, and the Y direction will be the same. And because it's negative, like it is here, when it's negative, he's moving left. He's also going to be facing left. So let's hit save and go back into Unity. Before we do that, I have a bracket out of place. We're just going to delete that right there and put that right there, and that's going to line our brackets up so that our fixed update is right here with this code in here, and then our update is here with our face direction code, and it's all within our mono behavior class. Let's go ahead and hit save and go back here into Unity, and now I'm going to hit play. And so now when I move back and forth, our character changes direction with our movement. So now what we're going to do is actually we're going to, first off, copy this, just like so. I'm going to paste it there with Control V. And actually I'm going to delete these two. And I know we put some work into putting these here, and the purpose of this series is to educate you. So you know now how to move an object using velocity and vector 2s, and now we're just moving over to moving objects with physics. So actually we're going to move it up here above our fixed update, because every time it updates, we want our body to be able to create this new vector 2, and we're going to manipulate how this works as the game moves on. So what we're going to do that's going to be different though is we're going to multiply this by current speed x. And so what we want to do is we want to be able to change our speeds, and the current speed x is the one we didn't apply a fixed value to because it's going to be constantly changing based on the other speeds. And then it's going to get applied to the velocity of our character's movement right here. So right above this, what we're going to do is we're going to put another if statement, and we're going to put if face direction x exclamation point equals 0. And then at the end, we're going to put some curly brackets. Now this is a new symbol right here where we have an exclamation point and a 0. Now down here, when we said that we wanted things to equal, we put an equal sign down here. When we put an exclamation point in front of an equal sign, it means not. So this says if face direction x does not equal 0. Basically, if the character is moving. And it is kind of a long way of saying things, but you'll see as this develops why we're doing that and why we're nesting everything inside this concept of him not moving. So the next thing we're going to do is inside this if statement, we're going to put another if statement. And it's going to say if current speed x is equal to 0. And I'm going to go ahead and put some more curly brackets. So we have what's called a nested if statement. So we're saying both of these things have to apply. If face direction x does not equal 0, and if current speed x is equal to 0. Now here we've put in two equal signs as opposed to down here we put 1. And the difference is that where we have 1, we are declaring the new variable here. We're saying that the transform.local is going to equal this. This is not, we're not changing current speed x, we're comparing it. We're saying that if it equals 0, down here we're saying we're changing it to the new vector 2, and we're changing it to the new local, I'm sorry, I'm going to the wrong spot. We're changing this rigid body to a new variable. And we're changing this to a new variable, or a new vector in this case. But when we use a double equal sign, we're saying we're comparing it. We're saying that when it equals 0. So inside of this statement, we're going to put current speed x is going to equal, oops, I messed that all up. Current speed x is going to equal minimum walk speed x. So if the face direction does not equal 0, if he's moving, and if his current speed is equal to 0, then, let's just get that out of there, that's a mistake, then his current speed is going to equal the minimum walk speed, which is that number right there. So now after this, we're going to have an else if statement. Oops. We want parentheses there. And inside this parentheses, we're going to say else if the current speed x is going to be less than the max walk speed x. And now we're going to put two brackets there. So here, if his face direction does not equal 0, if he's moving, and if the current speed equals 0, then it's going to be equal to the minimum walk speed. However, if it doesn't equal 0, if he's actually moving, then actually, if he is moving and he's less than his maximum walk speed up here, then the current speed is going to change. And now we're going to include another new coding concept called a function. Actually, we have used functions this whole time. Like I said before, this is a function, and the void update is a function, and so is the void fix update. And now we're going to create a whole new function, and we're going to be able to pass variables into it. So how that's going to work is that we're going to say current speed x is going to equal increase within, and then inside of that, we're going to put current speed x, comma, walk acceleration x, comma, max walk speed. So I'm sorry, this is supposed to be increase within bound because the bound is the max speed. So if he's moving, but he hasn't hit his max speed yet, we want to be able to adjust his speed. We want to be able to accelerate it slowly. So we want him to be able to start at, standing still. And then as he starts moving, he gets faster and faster and faster. And then he hits a max speed and then he maintains that max speed. So down here, right underneath our void update, we're going to create our function. So now to create this function, we're going to do something a little different. We're going to put the word float, and then we're going to put increase within bound, and then we're going to put a parentheses, and then we're going to put some curly brackets. So first off, the big difference is that we're going to put this word float here, and all these other ones had the word void in it. And the thing is that when you have void in front of something, it means it doesn't return anything. It just runs the code and that's it. In the case of this, as you'll see, this increase within bound, we want to do a calculation and we want a float at the end of it that we can make use of. So when we go up here and we have our increase within bound up here, we want to be able to change this current speed, which is a private float, and we want to be able to turn it into another float. So we are basically just taking in these different numbers. We're taking in the current speed. We're going to take in the walk acceleration.x, and we're going to take the max value speed, and we're going to perform a calculation with it inside this function, and then it's going to change the current speed. We're basically saying that we want to change the current speed based on all these other numbers to create this situation where our character will slowly increase to a max speed, and then we'll be able to apply it. So we're going to go back down here, and in our argument, we're going to put 3 variables or declare 3 variables that are going to represent these, but they can't be the same name as these. We're saying that we want to use current speed, walk acceleration x, and max walk speed. We want to pass it through the function, but to use them, we have to have slightly different names here. Otherwise, the code gets confused. So the first one we're just going to call value. We're going to say there's a float. We're going to call it value. We're going to call another float delta. And then we're going to call another float max value. So right here in our code, the first thing we're going to do is that we're going to say that value is going to plus equals delta. So we want to create a numerical value for delta, which is our acceleration here. So what we're saying is that we want to increment the value. We want to take the value, and then for every frame, we want to increase it by 1. That's what we're saying here, plus equals delta. So for the first frame, whatever the number is, let's say it's 1, delta is going to equal 1, and then the next time it's going to equal 2 and 3, and it's going to add and increase this value over and over again, and it's going to apply it to this. So then what we're going to do is we're going to have an if statement, and we're going to say value greater than max value. And then we're going to have our curly brackets. So we're increasing the number, but we don't want it to be larger than our max speed. We want our current speed, which is what value represents. We don't want it to be bigger than the max speed. So that's what we're saying. Like if it is greater than max speed, if it actually gets bigger than max speed, we want to adjust it. So I'm going to say value is going to equal max value. So we're basically just creating our own speed limit. Spelled that wrong. This is basically what we're doing here. And then finally, when this is all done, we want to return value, because that was the purpose of this. We need to return a float. This is the float right here. We increase it slowly. The moment it hits the max value, we set it to the max value. So it increases, hits the top speed, and our character remains at that top speed till we slow him down. And then that's the value that goes here. And that all becomes then equal to the current speed. So now let's put a semicolon here at the end, which I just noticed that was missing. And then we're going to hit save, and we're going to go into Unity. I'm going to let it compile. And now, as you'll see, I'm going to hit play. And what's going to happen is that I'm going to push my D key, and as you can see, he moves, and he's slowly getting faster and faster and faster as he goes along. And he can do it in the other, actually, no, he can't do it in the other direction because we haven't added the other direction. In the new code, he doesn't quite know how to change direction yet. We set the tone for him to be able to change the way he faces based on our movements, but we have to now put in our bool here for him to change direction. But let's go back and just look at it for a second, because the purpose was to see how he increases speed. I'm just going to touch it, and now I'm not even holding on to it, and you can see that he's just getting faster and faster and faster as he moves, as I keep pushing it. So that's exactly what we wanted, but currently, that's a little better, that we can see that he increases speed as I hold down the key, and then he's going to hit a max speed, and then that's going to be his constant speed until something slows him down, which right now we don't have. In the next video, we're going to apply the code that's going to allow him to decelerate and stop and turn with more precision. So now in our code, right here, after this if statement with the face direction x does not equal 0, we're going to go ahead and define what changing direction is. So we're going to say that is changing direction is going to equal to current speed x being greater than 0. And when we say and, just like up here when we're making a comparison, rather than redefining, we use two ands. So and face direction x times move direction x is going to be less than 0, and a semicolon at the end. So our change direction, which is a bool, remember he is changing direction or he's not changing direction, we're defining that as the current speed being greater than 0, and so both these things have to happen, and face direction x times move direction x is less than 0, or basically negative. So that's what we want that to be. So now we are going to create a situation. Well, what happens if he is changing direction? So if changing direction, or I'm sorry, oh no, I'm sorry, that was right the first time. So if he is changing direction, so if this is true, if he is changing direction, then his move direction x is going to equal negative face direction x. Because remember, when face direction x is negative, it's a negative number, he's moving to the left. So then, if that's not happening, if it's false, else move direction x is going to equal face direction x. So just like in the previous video, when he's negative, he's moving to the left, and when he's positive, he's moving to the right. We just put it into parameters which weren't just so distinct and hard numbers. We're basically creating a little bit of the idea that things can vary. So let's hit save and see how this turns out. So now let's hit play. And now when we move our character, he can go back and forth, and he can also stop. So he's not just sliding off of the platform anymore. And if you can see, he does speed up a little bit. He does go from stop, and he speeds himself up. And more importantly, look down here. Here's our move direction x. Remember we had to apply a number to that? Well, because it varies on how his speed is, how he's building his speed and getting to his current speed, this now tells us, what he's doing. He's 0, so he's completely still. Move it to the right, he's a positive number. Move it to the left, now he's a negative number. So in the next video, we're going to add even more physics to make his turns a little faster and add a little bit more good feeling to the controls that players like. So that's it for today. As always, thank you for watching. Like this video, subscribe to my channel, follow me on Facebook and Twitter, and support me on Patreon. And a big special thanks to all my Patreon supporters. All links are in the description below. See you next time.